Okay, let's go through this tutorial. This is chapter 10, Dates and Times, from this book here, which is Data Science for Psychology. So let's go back to chapter 10. So this chapter contains essential commands for creating and manipulating dates and times. So why are we doing this? Because if we want to work with time series, and in particular financial time series, financial data is usually, a lot of it is time-based, we need to know how we can handle dates and times in R. And there's a package which is part of the tidyverse called Lubridate, and it's sort of a lot easier to use than just the base R times and dates. So we're going to get to Lubridate here, but first let's go through the beginning. So this chapter contains essential commands for creating and manipulating dates and times in R. Computing with dates and times is complicated as it needs to take into account many challenges of culture, history, and science. Seemingly simple questions like what time is it, how old is X, how long ago did some event Y take place, get surprisingly complicated when we become aware of the relativity of time in terms of location, let alone physics, and the large variety of units and standards involved in measuring and reporting time. It seems like such a simple thing, but it's not that simple, and especially in the base R, not particularly simple. But with some of the additional packages we'll use, hopefully it will be a lot easier to work with dates and times. So this is a kind of interesting diagram. It's on the outside here is what we generally do in data science. So we prepare our data, we explore it, we wrangle it, and then we do some programming with it. And then inside here, I guess, are some steps that we employ when we're preparing, when we're exploring, we visualize, transform, explore it further. We work with tibbles, importing data, tidying data, joining data means like combining data frames and things like that, working with text and time data, functions. And so anyway, here's the part that we're concerned with, time data. Okay, he goes on to say, as an illustration of the pragmatic challenges posed by references to dates and times is provided by the suggestion, let's meet tomorrow at 12 p.m. Although such a sentence seems common and harmless enough, most people struggle when they begin to think about it. Really? Maybe, I guess so. First, the meaning of tomorrow only gains its referent in relation to what we consider to be today. But even if tomorrow's date was clear, does the appointment time refer to 12 o'clock, to early morning, or to midnight? I think it's clear, I think, right? It refers to this one, noon, but anyway, okay. And these two seem to be the same, but I guess he's saying that they could be different. Not really different, but okay. So he says, if even such simple sentences can seem ambiguous, incorporating a variety of conventions, languages, as well as cultural idiosyncrasies, for example, different notions, expressions, and measurements of time, they're bound to create confusion. Thus, the key challenge in dealing with dates and times consists in the cultural, historical, and local conventions that need to be taken into account. Okay, so this is the problem that makes dates confusing. He says handling all this messy stuff, messy human stuff, requires a good deal of conceptual clarification, distinguish between time points and different types of time spans, lots of standardization, for example, time shifts and time zones, and technical sophistication, appropriate data types and tools. Okay. So he says we're going to start out with base R, then we're going to move to Lubridate, and then maybe play around with that a little bit afterwards. So he says doing all of this with R and learning how R works, he says we will see that studying dates and times can teach us a lot about the world we live in, maybe. Okay, but before we get carried away, he says it's time to get started. Okay, he says, having braved the challenges of text data, so that was in chapter 9, there are at least two other prominent data types that we have not addressed so far: dates and times. As we have seen for text, our ignorance of these data types is partly due to our number-centric perspective on computers and science. So, typically when we think about computers and science, we think we're working with numbers, but it turns out that a lot of times we're working with non-numeric data as well. Another reason why time-related data appears so late in this book and often is absent from introductions to data or computer science is that working with dates and times tends to be difficult and complicated. In fact, any serious attempt at dealing with time will sooner or later reach the cognitive impasse expressed in the popular quote of St. Augustine: "We seem to know an awful lot about time, yet struggle to explicate its nature and the relevant details." Okay. Okay, so here are some of the challenges that we face with quantifications of dates and times. So the year 2021 is defined by the Gregorian calendar. Let's just take a look at the Gregorian calendar. It says it was introduced in 1582 by Pope Gregory the Eighth. What does he look like again? There he is. Okay, as a minor modification of the Julian calendar. What is the Julian calendar? The Julian calendar was proposed by Julius Caesar a long time ago, 46 BC, and was a reform of the Roman calendar. Okay, so there's an interesting story about that, and the how this guy named Julius Caesar, originally the Roman calendar only had 10 months, and you can sort of figure that out when you look at the names of the last few months, like October, November, December, September, October, November, December. If you know those words, they mean September means 7, October comes from the word octo, 8, November for 9, and December is 10. So it sounds like the December is the 10th month, but of course it's not. It's the 12th month. So this guy, Julius Caesar, added in an extra month. We call it July, and it's after his name. So he wanted to create a new month according to his name. So that's why it's July. And then the person who succeeded him was named Augustus Caesar. He also added in another month called, or maybe that they were both, I don't know when they were added, but anyway, August comes from Augustus. Anyway, so they decided that they deserved their own months. Okay, so the Gregorian calendar is the kind of basically the Julian calendar, but it changed the average year from, I don't know, something. Okay, you can read this yourself. So here it says the calendar was introduced as a revision of the Julian calendar. The Gregorian date of any event happening in the years 1901 to here is 13 days ahead of the corresponding date in the Julian calendar. So they're not the same, the Julian calendar and the Gregorian calendar. There's anything in this range is actually 13 days different than it would have been in the Julian calendar. Okay, there's some more complications here. In our calendar, every year that is exactly divisible by 4, so is called a leap. Has a leap year. Is a leap year, and leap years have 29 days in February, except for years that are exactly divisible by 100. But these are centurial years. But these centurial years are leap years if they are exactly divisible by 400. Okay, I didn't know any of this. So I guess you could say that it is more complicated than we thought. For example, the years 1800, 1900, 2100 are not leap years because they're not divisible by 400. But the years 16, 2000, and 2400 are leap. So that's probably much more than we wanted to know about dates and leap years. But anyway, okay. Okay, so this year can be expressed in Roman numerals like this, and you might recognize some of this. M stands for millennia. It comes from the same word as millennia, is related to the word millennia. And the way that Roman dates work is if you have 2,000, you have to put two 1,000s together. So that's different than here. When we want to say 2,000s, we just put a 2. We don't have to put 2 and or 1 and 1 or something like that. It's a different way of expressing dates. Anyway, this means 2,000 and then 2 x's. I think most people know that's 21 in Roman numerals. More generally, dates and times contain numerals that represent numbers like 2, 20. Okay, good, that's true. But are also represented as character strings. Okay, so this is something that we have to learn about or live with in R. So dates are character strings often. These strings often contain additional names, for example, Monday or July, in a specific language, and abstract symbols, punctuation marks like this and this. Despite this wild mix of numbers, alphabetic characters, and other symbols, we often want to calculate with dates and times. So, if we have today and it's represented as whatever, July 21st, 2021 or something like that, then we also have the fact that today is Monday and whatever, and then we also have these things in there, and then somehow we want to be able to calculate with dates and times that are represented like that. Well, you can imagine that there has to be some stuff going on there. It's not completely straightforward. How do you subtract Monday from Tuesday or something like that? Okay, a little more about the difficulties. When representing dates and times in numeric form, doing arithmetic is complicated by local differences in multiplicity of units and countless cultural and historic conventions. Well, we just saw, that there was the Julian calendar and the Gregorian, so there's different conventions. If scheduling meetings often seems hard, that's true. It's hard to get everybody to agree to meet at a certain time. Everybody's schedules are different. Everybody's busy at different times. But on the other hand, so is calculating their dates from a computer's perspective. When agreeing to meet every 2 weeks, the time difference between subsequent meetings, of course, is 14 days. When agreeing to meet every month, the time difference between meetings varies based on the number of days in each month. And for solving basic tasks like computing someone's current age in years, we first need to know our current coordinates in time and space, and to obtain an accurate result. So you have to know where you are, because there's time zones and things like that. And if these tasks do not seem yet daunting enough, start thinking about time zones, leap years, and leap seconds. I don't want to think about leap seconds, but I guess somebody has to or had to. Thus, dates and times are context-based and can get complicated for many good reasons. For example, they depend on various units of magnitude and measurement: years, months, days, etc. Dates, hours, minutes, seconds, or times. Their values depend on locations and time zones. Daylight savings time is something in certain countries. They change their clocks, actually. I think in November, they change their clocks, and maybe some time in the spring they change them back. It's to create more daylight, I think, during the day. So in the winter, anyway, we don't need to go into that. Their values and elements depend on cultural conventions, weeks starting on Sunday versus Monday, and languages, and so on. They are regulated by standards, daylight savings times, coordinated universal time, and ISO 8601. They depend on pragmatic considerations like our current perspective. An event X that happened yesterday has a specific time. Well, let's do X tomorrow. Typically denotes the day within X is to take place. I don't follow that. And communicative intents, 2 weeks or okay. Let's keep going. Okay, it says, fortunately, R provides a range of pretty good answers to St. Augustine's question. From a computer's perspective, dealing with all this messy stuff requires appropriate data types, standardization, and a range of tools of sufficient technical sophistication, and so on. When dealing with text data, so that was in the previous chapter, talking about text data in R, we saw that a key tool was regular expressions. For dates and times, the elephant in the room is provided by the POSIX standard. So we will learn about this POSIX standard. It's kind of the foundation of dates in R. As we will see, R provides rich functionality for objects that conform to this standard and corresponding functions for entering and extracting date and time related information. So once we get it into a POSIX standard, then we can get extract the date and extract the time and so on from that kind of POSIX element.